But what made the Super Soaker so successful? Well, underneath the bright plastic we find some surprisingly clever engineering that is worthy of more than just a toy water gun. And believe it or not, its innovation all began with a bathroom experiment. Who was the mastermind behind this aquatic escalation? A guy named Lonnie Johnson. And calling him a toy inventor doesn't really cut it. Aside from coming up with the Super Soaker, he also has degrees in mechanical and nuclear engineering, worked at NASA's Jet Propulsion Laboratory as a systems engineer during the Galileo mission to Jupiter, and he worked on the highly classified B-2 stealth bomber program while in the Air Force. Oh, but he did also help design the Nerf blaster. The story of the Super Soaker begins in 1982. Lonnie was experimenting with nozzles he machined for his next invention, a heat pump that uses water instead of environmentally harmful refrigerants. He hooked up one of these nozzles to his bathroom tap and turned it on. A surprisingly powerful stream of water erupted from the nozzle. And in that moment, Lonnie had an idea. A working prototype for a new type of water gun soon followed, and it was clearly better than commercially available water guns. We'll cover how this innovative system works in greater detail shortly. Lonnie was convinced his concept would make a wildly successful toy. So he went out to find a company that was willing to manufacture it. But unfortunately, luck was not on his side. He hit a series of roadblocks and years of frustration followed. Until one day, in 1989, the ever-determined Lonnie met with the Laramie Corporation and made his point by firing a jet of water across their boardroom. The vice president of the company responded with, "Holy sh!" Mass production soon followed, and by 1992, the Super Soaker was the highest selling toy in the world. A rocket scientist had just disrupted the toy industry. Before the Super Soaker, water fights were just a damp disappointment. A typical water gun used positive displacement. Pull the trigger and a small piston pushes out water. This meant you had to work the trigger for every momentary squirt, each with the range of a sneeze. But the Super Soaker changed all that. Here's how it works. You pump the handle. Each pump forces air into the Super Soaker's iconic bottle, which also contains water. By using a one-way valve, air can flow into the bottle, but it cannot escape back out. Now, air molecules are a bit like tiny invisible ping pong balls, constantly bouncing off everything they come in contact with. As they do, they exert an outward force. Because this happens continuously and evenly across all surfaces, we describe it as air pressure. Pressure is the force applied divided by the surface area it acts on. And the more air you cram into a sealed container, like that of the Super Soaker bottle, the higher the pressure becomes. But why build up pressure like this? Because it is a store of energy, just like a stretched out rubber band or a compressed spring ready to be released. So, when you've snuck up on your unsuspecting target, the hard work has already been done. You just need to pull the trigger. As the pinch valve opens, the compressed air rapidly expands and forces the water out through the tubing. This happens because air moves from areas of high pressure to low pressure. With the pinch valve open, the system wants to equalise with the lower atmospheric pressure outside. Using pressurised air like this in mechanical systems is called pneumatics. It's the same principle that swings open bus doors, applies the brakes in heavy trucks, and fires high-powered nail guns. And now, thanks to the Super Soaker, this power could be harnessed to drench your siblings. But the engineering doesn't stop there. There's also the nozzle, which is a precisely shaped narrow opening. This narrowing increases the velocity of the water, much like when you put your thumb over the end of a garden hose to make the stream go further. The continuity equation explains this effect. This says the amount of water flowing into the nozzle has to match what flows out. So, at the narrow outlet of the nozzle, the water has to move faster to keep the flow balanced. Bernoulli's principle comes into play here too. It tells us that as water flows, its total energy stays constant. It just trades one form for another. So, when water squeezes through a nozzle and speeds up, its pressure drops. That's because some of the pressure energy is being converted into kinetic energy, the energy of motion. But note this ignores friction and turbulence, which drain energy from the flow. So, if the nozzle is too small, it restricts the amount of water getting through, leaving you with a stream that's low in mass and punch. A well-sized nozzle, like that of the Super Soaker, finds the sweet spot. Enough velocity gain and enough mass to create a stream with real momentum. Using these engineering principles, the Super Soaker allowed you to hit your target with a long-lasting stream from up to 50 feet away. In fact, that's where the original Super Soaker, the SS50, got its name, 50 feet. But the original Super Soaker system wasn't perfect. As you fired, the stream continuously lost strength. That's because as water leaves the bottle's effective volume for holding air gets larger. And as Boyle's law tells us, when the volume of a sealed container increases, air pressure decreases, which leaves us with less force to push out the water. To get around this, Lonnie and his team developed the CPS range. This stood for Constant Pressure System. Instead of relying on compressed air, these next-gen water blasters use a rubber bladder. Pumping the handle forces water into the bladder and stretches it like a balloon. As the bladder expands, it stores elastic energy as its material wants to snap back into its original shape. Then upon pulling the trigger, the bladder continues to push on the water with almost constant pressure, giving you a more consistent blast from start to finish. But the CPS system didn't just make the stream more consistent, it delivered more range and power. Enough to completely soak Mum's freshly hung washing again. The Super Soaker reinvented the water gun through clever engineering and became a global sensation. But for its creator, Lonnie Johnson, this was just the beginning. He had far bigger plans, ones that reached well beyond the toy shelves. Since the Super Soaker first burst onto the scene, some 175 different models have been released, and total sales have exceeded $1 billion. On top of this, the Super Soaker was inducted into the National Toy Hall of Fame in 2015. Being a literal rocket scientist, some joked its inventor, Lonnie Johnson, was overqualified to accept this award. Which is probably why in 2022, Lonnie was also inducted into the National Inventors Hall of Fame. And today, Lonnie is living it up with the millions he earned from the Super Soaker. He's all about big boats, bling, and bottle service. No, hang on, that's not right. As a true testament to his character and love of engineering, Lonnie has poured his personal fortune into starting research and development companies. He's now working on things a little more serious than toy water blasters. We're talking about solid-state batteries that have doubled the energy density of lithium-ion batteries, and devices that turn waste heat into electricity with high efficiency and no moving parts. Lonnie's been so busy with this stuff, the number of patents he now holds to his name is over 150. But perhaps most admirable of all is Lonnie's commitment to inspiring the next generation of inventors. Every year at the Johnson STEM Activity Centre, thousands of students dive into robotics, programming, and hands-on problem solving. Lonnie has also used the Super Soaker prototype as a tangible reminder that world-changing ideas can start off small, and sometimes even originate in a bathroom. The Super Soaker. It's probably not the first thing that comes to mind when you hear the term engineering marvel. But engineering, at its core, is about solving problems in elegant and novel ways with the help of scientific principles. And the Super Soaker, I think, is a clear example of this. Sure, it didn't launch anyone into space. It did, however, do something perhaps just as hard. It revolutionised summertime for an entire generation.